Hello everyone, welcome back to another very interesting question, conceptual question, very good conceptual question, properly IIT-JEE advanced syllabus. It's a multi-correct answer question taken from Pathfinder on system of particles, center of mass concept. Okay, let's read. A small block, small meaning size can be neglected, meaning that rotational inertia, all that are not considered here. Rest meaning initial velocity 0 on a flat bottom of a deep bowl. Deep bowl they are saying, meaning the block cannot escape out of the bowl. So it's always inside. Okay. And that bowl is placed on a horizontal floor. Okay, you can see that. There is no friction between the block and the bowl as well as between the bowl and the floor, meaning no friction anywhere. So yeah, you can conserve mechanical energy. No dissipation of mechanical energy here. Okay, that's one. Next, total mass of the bowl and the block is capital M. So total mass he has given, now he had not given individually what is the mass of the block and bowl. Let's assume mass of the bowl as M1, mass of the block as M2, M1 plus M2 equal to capital M. Okay. If the bowl is given a horizontal velocity by a sharp hit, so we are giving a horizontal velocity, let's say I'll take it as U, you are hitting the bowl, you are not touching the block there, so block will continue to be at rest immediately after the hit, only the bowl starts moving with some initial velocity U, let us say. Subsequently, it is seen that the block rises to a height, maximum height h, sliding on the walls of the bowl. So why would the block move when we hit the vessel there, bowl? So to understand that, maybe we can study that from bowl frame after it is hit. So with respect to bowl, the block will start moving backward with the same velocity, and then it eventually reaches to the edge and then climbs up and then slides down back. So and then slides forward. So it will be oscillating back and forth, slides back and slides forward on both the walls like that. So it's going to be oscillatory motion, of course not simple harmonic motion. So definitely it will climb up the walls. So when it reaches to the maximum height, the height is h they had given, h is given, very good. Which of the following statements are correct, we need to identify. So he is talking about maximum kinetic energy of the bowl, he is talking about minimum kinetic energy of the bowl. So he is talking about those two, maximum kinetic energy and minimum kinetic energy. The first option he says that maximum kinetic energy of the bowl is equal to capital mgh, not small mgh, capital M, knowing total mass into g into h. So interesting formula. In fact, A option is coming out to be correct. Probably you can remember it as some interesting result. So that could be useful later on for some other good problem to solve. So first of all, when will the bowl have maximum kinetic energy? See, there is a transfer of energy from block to bowl and bowl to block. We have given energy only to bowl first, and initially block will be stationary, it doesn't have any energy. So as long as the block does not carry any energy, take energy from the bowl, you can see that bowl will have the maximum energy. The moment it is transferred to the block, so there is a loss of kinetic energy for the bowl, and so bowl will subsequently going to have lesser kinetic energy. And bowl is not going up or down, so it is not going to change its potential energy. So maximum kinetic energy of the bowl would be when the block has zero energy, zero kinetic energy, zero potential energy, and that's the starting point. So initially it will have the maximum kinetic energy. Okay, that much we can understand. Whether it is coming out to be equal to capital M into G into H or not, we need to check that. And he is saying in B option, if the bowl is lighter, let's say M1 is the mass of the bowl, if M1 is less than M2, then minimum kinetic energy of the bowl is 0, is saying we need to verify that. And to predict a minimum kinetic energy, suppose it is not 0, some other value, 0 or non-zero, if it is non-zero, how much? If you want to predict the minimum kinetic energy, he says that we must know the ratio of the masses. Okay, that's another thing. To predict the maximum as well as the minimum kinetic energy of the bowl, we must know the ratio of the masses, is saying. Straight away I can strike off D option. So can you tell me why so? Because what I see that maximum kinetic energy he is talking about. To find maximum kinetic energy, I don't need to know the mass of the blocks or mass of the bowls. I know that maximum kinetic energy of the bowl would be in the beginning only. So minimum maybe I need to verify it what happens, but maximum I know it. I don't need to know the masses. That's why D option is eliminated. So we need to focus on the remaining options now. So let's focus on option A. I'm going to use the first concept, concept 1, conservation of mechanical energy. We have seen that there is no dissipative forces there is no external force after the impulse is given. So total energy has to be conserved. there is a loss in kinetic energy of the system, both bowl and block together. If they lose kinetic energy, entire system, that will be converted into potential energy. So that is one thing, and potential energy increased by only the block there. I am assuming the mass of the block to be m2 there. Okay. And we can also use conservation of linear momentum, but only in horizontal direction, not in vertical direction. Momentum of the system in horizontal direction is constant. So when momentum is constant, velocity of center of mass in x direction will be constant. I am taking x axis as horizontal. So initially, let's say u was the velocity of the ball and mass of the ball is m1. So m1 into u is the total momentum of the system initially, and that too horizontally, and divided by total mass is going to be constant, and that is continues to be constant only. That is concept 2. And concept 3 is that when they go to the maximum height, at the maximum height, the block cannot have vertical velocity. Horizontally it will have definitely, but vertically it will not have any velocity. Vertical direction velocity for block, I am taking number 2 for block, v2 in y direction has to be 0, and anyway ball is not going to move vertically, so only block will have vertical. If that is also having vertical 0 velocity, that means there is no vertical velocity as a whole for the entire system. Then velocity of center of mass in y direction will be 0 at the maximum height, and remaining times center of mass may have vertical velocity also because of the motion of the block vertically. And velocity of center of mass at that moment is only horizontal velocity, which we have already calculated as m1 into u by m capital M total mass. And at the highest point, what happens if you use rigid body constraint, horizontal velocities are equal, so v1 equal to v2, and that is going to be only horizontal velocity, so relative velocity will be 0. So this is also one important concept. This at maximum height, this is very important concept, basic concept only. You would have seen many questions, and you are supposed to be very comfortable with these ideas. So these are the 3 concepts we are using here. So it's a good conceptual question, definitely. Now I am going to use one more idea. It's not necessarily a concept, but writing kinetic energy of the 2 body system, translating body system in this form would be convenient, especially in this kind of problems. So kinetic energy of 2 body system is half of m star. M star is reduced mass. I use the symbol m star. Some books they use mu. Their friction coefficient we use mu. So m star I will write it generally. That is m1 m2 upon m1 plus m2. That is internal kinetic energy plus half of capital M total mass of the system into VCM square. This is also very standard result. I am not deriving this here. I am just taking it. Those who require it, if you put a comment, I will just explain it later. But this is one important result you have. So half of m star into V relative square plus half of mass of the entire system into VCM square. The second term is called kinetic energy of center of mass. The first term is called kinetic energy with respect to center of mass, otherwise you call it as internal kinetic energy. So that's what you have. Okay, now between initial and maximum height, you know that at maximum height V relative is 0. Initially block was stationary, only the bowl was going with u velocity. So if I use that Ke loss half of, see this term will not be there changing anyway, because center of mass initially equal to finally will have same velocity horizontally. So you have only the other component, only half m star into V relative square only will be there, that only will change, and that too V relative is 0 finally, u relative is nothing but u. If you substitute that, you will get half m1 into u square, that is initial kinetic energy of the ball is coming out to be capital M into g into h. Very good, excellent result. So this is a very good conceptual point. I hope you understand that. Here this part I am reiterating once again, this part is not going to change. Center of mass kinetic energy associated with motion of center of mass. Only the other internal kinetic energy changes, that gets converted into potential energy. Okay, so the option A is correct. Now let us go to the other options B and C and all that. Let's go to BC to check whether kinetic energy minimum will be 0 or not, when will it be 0 and so on. So now the idea here is, if kinetic energy minimum for the bowl is going to be 0, then definitely it is going to change the direction of motion. If the bowl changes the direction of motion, so initially it is going in horizontal direction, right side, let's say, after some time it is going left side, meaning whenever it is changing direction of motion in 1D, it should definitely come to momentary rest at least, and then go changing the direction there. So there will be minimum kinetic energy 0. So if it changes direction of motion, then kinetic energy will be 0 minimum. If it does not change direction of motion, then kinetic energy minimum will be at point A, and that's what I am claiming. So I hope you understand that. Try to visualize that. So as the block goes on the left part of it, on the left part as it is traveling, sliding up like this, you see that normal reaction will be backward, and it will have horizontal component towards left. So because of that, the bowl would be slowing down. So while going up, normal reaction is left side only, horizontal component. While sliding down also, horizontal component of normal reaction will be left side only. So throughout the motion of the block on the left wall, the normal reaction will have horizontal component only left side on the bowl. That's why the bowl will continue to slow down if it is continuing to move in the same direction. And so by the time it reaches to the point A, that's where you will have the minimum kinetic energy for the bowl. So if it is not 0, minimum kinetic energy, it will be 0 when the block reaches to point A during its back and down journey, back up and down journey. So now to find velocity at V1, I want to use at V1 when the block comes to V1, that point A, I want to find V1 and V2, and for that I will use conservation of linear momentum and conservation of energy. Conservation of linear momentum is okay, initially m1 into u, just after the hit, m1 into u is the initial momentum horizontally, and when it comes to here, let us say the bowl is having v1 velocity, the block is having v2 velocity, so m1 v1 plus m2 v2 is the total momentum. The second one is conservation of energy, I have to write, but conservation of energy, kinetic energy and all, it will be it's square, no? Right, you will get quadratic expressions. To avoid quadratic expression, I will use the equivalent of it, equivalent of conservation of kinetic energy. Anyway, potential energy is not changing from initial to point A. So whenever you have the chance of writing conservation of kinetic energy between two bodies, you can write E equal to 1, coefficient of restitution equal to 1. So initially only the block was going, relative velocity before was u, finally relative velocity is v2 minus v1. So by using these two equations, we can solve it and get v1 like this, v1 equal to m1 minus m2 upon capital M into u. So for it to change the direction of motion, v1 has to be negative. If v1 is negative, meaning m1 has to be less than m2. m1 is mass of the bowl there, so bowl should be lighter than the block. For that, then kinetic energy minimum will be 0 there. Otherwise, if m1 is greater than m2, then this is the velocity, and that corresponds to minimum kinetic energy of the bowl there. So that B option is correct only. What was he saying? In B option, he was saying that in order for the body to have minimum kinetic energy 0, the bowl should be lighter, he is saying. That is correct only. m1 should be less than m2. That's a point I got. So B option has been verified in this explanation there. So now let us go and try to understand the remaining things, C option also. To predict minimum kinetic energy of the bowl, we must know the ratio of the masses, that is correct only. So A is correct and we have discussed that, B is also correct and C is also correct, D is going to be incorrect there. So I hope you understood. It is a very good conceptual, basic conceptual question, and if you have any doubt, please let me know. I will be very happy to explain that. With that, I will conclude here. I will come back to you again with another very interesting topic. Stay tuned. Until next time, goodbye.